Hello everyone. Welcome back to machine learning sessions. In this session, let us discuss about inverting resolution. Okay. So in order to understand this topic, first of all, you should know about the resolution operator in the form of proposition and inverse resolution operator in propositional form. And with the help of that, we will be studying the first order resolution, and we will also study inverting the resolution in the first order case. Let us get into the details. So first, let us see what is the resolution operator. Okay. So first thing, why we need a resolution rule is for deductive inference in the first order logic. Okay. So to deduce one formula for something else, we will be using this resolution rule. So we are already aware of this definition of the resolution rule. That is, let L be an arbitrary propositional literal and P and R be arbitrary propositional clauses. Two clauses we are taking and one literal we are taking. So the resolution rule is whenever you add this propositional clause P with the literal L and you are adding the other propositional clause with the negation of the literal, then it will give you the result as PRR. So why it will give? Because either L or negation L, only one will be true, and here we are using a R here. So obviously we will be getting PRR. So this is the resolution rule. Based on this, we will be trying to deduce the resolution operator. So these are the steps that we will be using in the resolution operator. So two clauses are given, C1 and C2. Then we will be finding a literal capital L from clause C1 such that the negation of it should occur in the other clause. So such one you should choose as a literal. Okay. So from the resolvent C, by including all literals from C1 and C2, except for L and negation L. Okay. So the set of literals occurring in the conclusion will be, so from C1 you have to remove L, and from C2 you have to remove negation L, and you perform a union on that. That will be your conclusion. Let us understand this with an example. Let's take C1 as pass exam or no material, and C2 as no material or study. So now, can you guess which one shall we choose as a literal? So that literal should be in normal form in one clause and negated form in the other clause. Okay. So let us take this as L. Okay. So let us take the no material as L, and let us take this no material as negation L. So here it is in the negated form. This I am taking as L. You can take either way also, no issue. So now from these two, okay, so what I should do from C1, I should remove my L. So that means this should be removed. And from C2, negation L should be removed. So that means these two should be removed. So then what I will be getting? PRR, right? So pass exam or negation of study. From the formula, this is what we are obtaining. So this is about resolution operator in the propositional form. So now let us study inverse resolution operator in the propositional form. So here we will be taking a clause C1 and conclusion C. And in this, we have to find a literal L such that it occurs only in C1, not in C. So then what we do is, for C2, from C, we will be removing C1 minus L. That means, first of all, from C1, you should remove that identified literal. Then that again, you should remove from the conclusion. And to that, you have to perform a union of negation L. Let us understand this with an example. This is our C1, pass exam or negation no material. Then our conclusion is pass exam. So now in C1, out of the two, which is not there in conclusion, no material is not there. So this I have to choose as L. So from C, I have to first remove this one. Okay. So what is left over? Pass exam is left over. So that is the result of our C1 now. So this C1, again I have to subtract from C. So this pass exam, I have to remove. So then whatever is left over in C, that should be unioned with negation of L. So what is negation of L? L is no material, negation of no material. So negation of negation is positive. So here I will be obtaining no material. C2 is no material or negation of study. So this negation of study is from my conclusion, that is union with negation of L, that is negation of no material. Okay. So this is how the inverse resolution operator is working. So from these two, what you should get is, for the inverse resolution, always we are taking a clause and a conclusion. Okay. In the resolution operator, we are taking two clauses and trying to identify a conclusion. So now let us see the first order resolution. So this is based on unifying substitutions. So first of all, what is substitution is? It is any mapping of variables to terms. That means one particular term we will be replacing or substituting it with a variable. For example, here theta is our substitution. So here x such that Bob. So that means wherever you see x, that has to be replaced with Bob. And wherever you see y, that has to be replaced with z. Y should be substituted with z. X should be substituted with Bob. That is the meaning. So now W theta is the result of applying the substitution theta to some expression. Okay. So let us take one expression. So if L is a literal, father of x comma Bill. So that is our expression, and theta is the same thing. X should be replaced with Bob and y should be replaced with z. So then what we will obtain? So here x has to be replaced with Bob. Then what I will obtain? Father of Bob comma Bill. Okay, so this is my L theta. On L, I have applied a substitution theta. So then this is my result. So now here theta is the unifying substitution. Okay, so in this case, we have taken only one literal. So now let us take two literals, L1 and L2. So if L1 theta is equals to L2 theta, then we call theta as an unifying substitution. For example, let us take two literals. L1 is father of x comma y and L2 is father of Bill comma z. And theta is x has to be substituted with Bill and z has to be substituted with y. So then what will be your L1 theta? Here I am telling theta is a unifying solution for L1 and L2. That means L1 theta is equals to L2 theta. So let us verify is it true or not. What is my L1? First, let us calculate L1 theta. L1 is father of x comma y. So what is theta? X has to be substituted with Bill. So I will be getting father of Bill comma y. Father of x has to be replaced with Bill comma y. So what is my L2? L2 is father of Bill comma z. So where z has to be substituted with y. So father of, this is L2 theta. Father of Bill, and in place of this z, I am substituting y. Okay. So now both are equivalent. So I can say theta is my unifying substitution. Okay. So here it is given. In some cases, we have to find out what will be the unifying solution. So in that case, you have to check like this and take what will be the unifying solution, unifying substitution. Okay. So now let us see the resolution operator in the first order form. So here is the algorithm. We have to find a literal L1 from clause C1 and literal L2 from clause C2. And we should also find a substitution theta such that L1 theta is equals to negation of L2 theta. Okay, from the resolvent C, by including all literals from C1 theta and C2 theta, except for L1 theta and L2 theta. So you just carefully observe the wordings. So, okay, from C1, except L1 theta and negation L2 theta they are telling. So that means from C1 you have to remove L1 and from C2 you have to remove L2. So then this will be your conclusion. From C1, remove L1 and then apply a substitution theta. Similarly, from L2, from C2, remove L2 and apply the substitution theta. Okay, so let us take this example. Let us take C1 as white of X implies span of X. Okay, so, and C2 is span of Fred. First of all, to proceed with, this is in the propositional form. This I need to convert it to a clausal form. Okay, so P implies R is P or negation R. Already you are aware of this formula. So using that, I'm rewriting it as white of X or negation of span of X. And C2, we are taking as it is. So now what I should do from C1, I have to take, identify the literal first. What is L1? L1 is negation of span and L2 is span of Fred. Okay, so here this same literal is in negated form under normal. So like this we are selecting. Okay, so span we have selected and here it is in a substituted form. Here it is in X. So here you can understand where should you take substitution and what should be your substitution. Okay, so in order for these two to be the same, I have to substitute either my X with Fred or Fred with X. So what is the substitution that I am taking is X is substituted with Fred. That is the assumption I am taking. Okay, so then I need to verify whether my L1 theta is equals to negation of L2 theta or not. Okay, so what will be my L1 theta? So in L1 theta is negation of span. X is replaced with Fred. Okay, and then negation of L2. So here a negation is just applied. Here nothing to substitute. So the result of this we are getting is negation of span of Fred. So now we should find out the conclusion. What should be our conclusion? From C1, I have to remove L1. Okay. So what is my C1? This is my C1, right? From this C1, I have to remove my L1 and apply a substitution. That means in place of this theta, I have to apply Fred. Okay. So this is my L1 and this is my L2. Okay. So then what I should do? I should remove L2 from C2. Already there is only a single literal here. So if I remove this, I will be getting a 5. Okay. So 5 into theta, nothing to substitute. So this is 5. So the conclusion. So these two has to be performed an union on, we have to perform a union on these two. So ultimately the conclusion that you will be getting is white of Fred. Okay, so this is how the resolution operator works in the first order form. So now let us see inverting resolutions. So now let us see inverting resolution in the first order case. Okay, so already we have seen the unifying operator. So here what will be done is instead of taking one unifying operator, we have to split that into two, theta 1 and theta 2. Okay, so theta is a concatenation of these two. Okay, where theta 1 contains all substitutions involving the variable from clause C1 and theta 2 contains all substitutions involving variables from clause C2. So far, we have taken the same substitution whether the variable is occurring in clause C1 or clause C2. But here we are taking differently for C1 and C2. So then the inverse resolution is C2 is equals to C minus C1 minus L1. Okay, after performing this C1 minus L1, you first apply the substitution theta 1 and then you just subtract it from C and then you perform theta 2 inverse. You have to perform this substitution. This has to be united with, perform a union with negation of L1, theta 1, theta 2 inverse. Okay, so let's take one example and try to understand this. So here we have to learn the rules for the target predicate. grandchild of y comma x. This is the target that is given. And the training data is also given. That is these grandchild of Bob comma Shannon. Okay. So this is matching with these two. So we will take this as our conclusion. And also background information is given that father of Shannon comma Tom. Okay. So this is one clause and one more is also given, father of Tom comma Tom. Okay. Using these three, we should try to get the target predicate grandchild of y comma x. Okay, so already the train data is given, that is grandchild of Bob comma Shannon. So let us take this as our conclusion, and one of these two we can choose as L1 and L2. Okay, so any one you can just choose as C1. Okay, so far what we have discussed, we are choosing, one second, let me change my color. So let's take this as our conclusion C. So because we have to get the target predicate as grandchild of y comma x, so I'm taking this. You should choose. You should carefully observe from which one should be taken as C and which one should be taken as C1. How will you obtain the result? That you should observe. Okay. So this I'm taking as C and this I'm taking as C1. So now from these two, what I should do? First of all, I should get my C2. Let's try to get the C2. So first, what I have to do? From C1, I have to remove my L1. So first of all, I should identify a literal L1. Okay. So in these two, what is common? So common thing is Shannon. And here, if you observe, it is grandchild of y comma x. Okay. So let us start the substitution also here. Okay. Let me take this Shannon as x. Okay. Tom as y. Bob as z. Okay. So now we have to perform C1 minus L1. Okay. So what should be our L1? Let's come here. Okay. So this father of Shannon comma Tom, this I am taking my C1 and this I have taken as my C. Okay. So here I have only a single clause, only one literal I have. So this only I should take as C1 and the same thing I should take it as L1. So then what should I do? From C1, I have to remove this L1 as per the formula. So that means, so this will become null. And then I have to take a substitution also, theta 1. Okay. So let's take this as 5 or empty. And then we have to take a substitution for the Shannon. So already we have taken a substitution for Shannon. This we are taking as theta 2 inverse. One second, let me go back to this slide and let me show you the formula. So what we are doing from C1, I have to remove theta 1, sorry, L1. Okay. So C1 and L1, we have taken the one and the same. That is father of Shannon is our C1. The same thing is our L1. When I subtract, this is becoming null. Okay. And this has to be subtracted from the conclusion. Okay. So that means my conclusion remains as it is. But the thing is, I have to take a substitution for theta 2 inverse. Okay. So let us take theta 2 inverse as this is inverse resolution. Previously, what we have done in the resolution, given a variable that you are replaced with some literal, right? Suppose here it is Shannon. So wherever you see x, you replaced it with Shannon. But here what it is inverse resolution. So that means wherever you see Shannon, that you have to replace it with x. Okay, so that is what the assumption taken here. So Shannon we are replacing with x. So theta 1 is empty, theta 2 inverse is Shannon substituted with x. So now from this, what is the conclusion that I will get? Okay, the conclusion that I will get is grandchild of Bob comma Shannon, and this has to be performed a union with it has to be performed a union with negation L1, negation L1, theta 1, theta 2 inverse. What is my L1? It is father of Shannon comma Tom. So this has to be taken in the negated form. So negation of father of Shannon comma Tom. This I have taken. So on this first I have to apply the substitution theta 1. What is theta 1? Theta 1 is an empty set, nothing. So theta 2 now I should apply. What is theta 2 inverse? It is x Shannon has to be replaced with x. So that means this Shannon will be replaced with my x. So this is the result of negation of L1, theta 1, theta 2 inverse. Already we have the result of this part, right? So what is the result of this part that we obtained? It is grandchild of Bob comma x. Okay, grandfather of Bob comma x. So this has to be performed a union with negation of L1, theta 1, theta 2 inverse. Okay, this is the result now we are obtaining. So now again, let's take this as our C and let's take the other clause, whatever we have as C1 now. Let's repeat the step. Okay, so this is our C1 now. So here what we have to do, since I have a single literal here, so C1 and L1 one and the same. Okay, so whenever I perform C1 minus L1, again I will be getting a 5. On this, if I have to apply theta 1, there is nothing to apply. Pi on theta 1, nothing. Okay, and here I have to take a, okay, so this has to be subtracted from C. So now I should perform, what is my C? C is this one. So from this, I have to subtract this, and at the same time I have to apply theta 2 inverse. Okay, so now, so in order to apply that, okay, so now you should observe what should be the substitution that you should take. So here I have Tom as well as I have Bob. So in the previous slide, I already have taken the substitutions for this. I'll just show you once. Yes. So Tom is taken as Y, the substitution. Bob is taken with the substitution Z. Just I have taken in order. Shannon as X, Tom as Y, Bob as Z. So this is purely of your choice. You can take it in any order. You can consider anything as conclusion and anything as L1. Okay, it's purely of your choice. You will get different answers based on the substitutions that you are taking and the choice of your conclusion and C1. Okay, so this is my C1 I'm taking, and then I'm taking a substitution also. So then what will be the result already? So this will be my conclusion. So to that, what I should add, there is no change in my negation. From C, I have to subtract this whole part. So this whole part is anyhow 5. So C minus 5 remains C only. So the same thing, this has to be performed a union with. So union is represented with R all the time. So negation of L1, theta 1, theta 2 inverse has to be done. So okay, what is my L1 here? L1 is father of Tom comma Bob. Okay, so this has to be, Tom has to be substituted with Y and Bob has to be substituted. I didn't remember exactly. Okay, one is Y and one is Z. So let's see the result. Okay, Bob is substituted with Y. This should be my Y. Tom is substituted with Z. So, and here also in the conclusion, I have Tom. So this Tom has to be replaced with Z. And Bob has to be replaced with Y. So my final and conclusion is grandchild of Y comma X, or negation of father X comma Z, or negation of father Z comma Y. Okay, so this is about inverting the resolution. Okay, once if you simply don't follow this and you just leave it, but you have to practice. If you follow step by step, then you will understand this very clearly. Okay, I recommend all of you to practice the flow once, then you can perform it better. Hope you followed. If you like the content, please do like, share, and subscribe. And I would like to thank all my subscribers and all the people who are watching my videos. Okay, I'm noticing that there are many people who are watching but not subscribing. I need your subscriptions. Do subscribe. Thank you.